Hi guys, Mr. Johnny here. In this video I want to show you a little minuscule little circuit that I put together to drive an LED. And I planned to go and put that circuit inside of the base from this small incandescent lamp, as you can see. And it's really small one. Here is a regular one in comparison. Fitting that circuit inside of this base would be no problem. But this is quite tricky, because this thing is about 12 millimeters like that, and in diameter it is about 9 millimeters. I don't know if you can see it, but oh well. So first I went and used the linear current source to do that, to fit inside of that space, and it did the job quite well. But the application where I use it is a motorcycle, and that motorcycle doesn't have a battery. It runs an alternator, and the system there is not only an AC system, but it is a poorly regulated system. It's not really regulated at all. It is just limited. There is a little circuit built into the bike which prevents the amplitude from going beyond certain value, but it fluctuates a lot. That's why I decided to add a little current source, and it worked fine. But apparently that limiting circuit does not really work all that great, and this thing died twice. The one transistor which is actual transistor which passes current through the LED, this one on the left, is shorted. So I decided to go a little bit more complicated way, and now I cobbled together a little buck converter. Yeah. This thing is about the limit of what I can put on there. You can see two transistors there. You can see a diode there, which is a Flyback diode. That thing in a heat shrink is an inductor, about 120 microhenries worth. The resistors you can see there is 0603. It's bodged up, obviously, because there's just not enough space to do it the other way. The other side is the wire I hold it with is what's going to be connected to the central contact there, which you can see, where you can see the hole right now. It's going to stick through, be soldered. Then it goes through 0 ohm link as a 0 ohm resistor, purely for the fusible link. So if this thing shorts out, it's just gonna blow out and everything is gonna be nice. Then again you can see a diode and a tantalum 10 microfarad, I guess. Yeah, 10 microfarad capacitor. And yes, the LED, as you can see, I did some filing on it to make it into a diffused LED. There's one more look. At how tiny this thing actually is. It's ridiculous. As for the schematic, you know what, I can tell you straight away that the schematic on this you can find on Token Electronics, but I'm gonna actually make another video. Next video is gonna be about the schematic I found from the Token Electronics, and I found it to be working very nice. It's not the first buck converter that I built according to that schematic. It really works reasonably well. For the simplicity, it is awesome. It consists of two transistors, one choke, one capacitor really, for the feedback, couple of resistors, a flyback diode, and that's it. It's about as simple as it gets. So now I'm gonna go and crumble it in, make these two parts. Okay, I crammed it in there. Yes, the board is actually longer than the base, so it sticks out on purpose. Again, this base is ridiculously small. It's about the size of 470 microfarad capacitor rated for 16 volts. So yeah, it's small. It's freaking small indeed. And if you don't believe me, I'm gonna make a racket on a bench. I'm gonna go. Here's for 25 volts, alright? See? Very comparable in dimensions. Rather small. Now I'm gonna go inject hot glue there in the empty space. But before I do that, I'm gonna bring the power supply, which is set to 21 volts. Gonna put positive here, negative there. And you can see that LED glows. And yes, it indeed switches. It goes into oscillation. It's not really a linear current source. It is indeed a switching device. So that's that. Next video is gonna be about the schematic of this little beast. I've also installed the same kind of, use the schematic for another thing on that bike, namely the brake light. I installed two 1 watt LEDs there, or 3 watt, yeah, 3 watt, two 3 watt LEDs, and I run them at 1 watt each. They're in series and they are driven from the kind of same current sink switch, from the switch mode buck driver, the same circuit that is here, but on the larger board, because I have more space there. Why not to use it? And yeah, I run the LED at about 15 or 16 milliamps. That's why it's so bright, which is still a reasonable current. The application is gonna be the why it's green, because it's gonna be a neutral indicator. Okay, enough babbling. I'm gonna quit it here. So in the next video you will see the schematic. So far, thanks for watching. See ya.